On the same day NASA furloughed thousands of employees, a quiet anomaly appeared in the silence of deep space. During a routine scan from the Perseverance rover, mission engineers noticed a faint, slanted smudge, exactly where 3I Atlas was supposed to be. It was barely there, just a few bright pixels against the dark Martian sky, yet it changed everything. That tiny mark confirmed the object was real, but it also opened a doorway to far stranger questions. Because the latest images didn't just reveal something about 3I Atlas, they uncovered something unnatural. An interstellar intruder with a coma rich in carbon dioxide, puzzling traces of water vapor. A sun-facing halo where there should have been a tail. Anomalous polarization angles. And most baffling of all, spectral lines showing nickel without iron. None of it fit the playbook for comets or asteroids. None of it matched anything in our archives of known celestial objects. So what exactly were we looking at? The beginning of a rare cosmic coincidence? Or the deliberate veiling of something far beyond our understanding? October 3, 2020. While high-resolution images from Mars orbiters remained locked behind institutional embargoes, Perseverance's navigation camera quietly captured a 20-frame sequence that shifted the entire conversation. Those 20 consecutive frames, stacked and calibrated by JPL engineers, revealed a subtle but undeniable motion. A slanted streak gliding across the night sky perfectly aligned with where 3I Atlas was predicted to appear. The alignment wasn't approximate, it was exact. Using NASA's Horizons ephemeris, the projected path intersected the same pixel coordinates frame after frame, moving at a rate expected for an object tearing past Mars at nearly 60 kilometers per second. This wasn't a cosmic ray. It wasn't a sensor glitch nor a passing satellite. The smudge didn't blink out between exposures. It traced a smooth, unwavering arc, a silent traveler crossing the Martian heavens. Each image, taken seconds apart, was adjusted for the rover's precise location and camera angle. When those 20 frames were digitally stacked, random noise vanished, and persistent features grew sharper. What remained was a faint but elongated streak, hovering just above the threshold of visibility. Fragile, yet undeniably real. And the timing, flawless. The sequence began exactly as 3I Atlas reached its predicted closest approach to Mars, a window calculated weeks in advance by mission planners. The odds of a random artifact appearing in that same position at that same moment across 20 exposures are astronomically small. No other instrument on the Martian surface reported a similar detection. Yet, independent imaging specialists at JPL quietly verified the data. They examined the raw files for sensor defects, cosmic ray strikes, and atmospheric distortions. None matched. The only consistent explanation was simple and astonishing. Perseverance had, by a combination of timing, precision, and pure chance, captured an interstellar visitor in motion. It wasn't the detailed portrait that orbiters like HiRISE or Mars Express could have given us. The signal was faint, too distant for structure, too dim for a nucleus or tail. But it was, for now, the only direct photographic proof that 3I Atlas existed, moving exactly as predicted, following a trajectory that no Martian satellite or known debris could imitate. In a time when official channels had gone silent, this faint smudge from Perseverance became the only tangible anchor in a sea of uncertainty. It confirmed the object's presence, but left every deeper question about shape, composition, and origin hanging in the void. Across the solar system, a network of observatories turned their instruments toward 3I Atlas, each hoping to decipher what the faint smudge on Mars had begun to suggest. And with every wavelength, the mystery deepened. The James Webb Space Telescope, peering through the void in infrared, detected something profoundly unusual, a coma rich in carbon dioxide. Normally, in comets that wander through our system, water dominates by far. But Webb's NARSPEC readings showed a carbon dioxide to water ratio close to 8-to-1, an order of magnitude higher than anything seen before. To planetary scientists, that ratio was almost an insult to chemistry. It implied that this visitor carried a composition no solar-born object could have. Either it formed in a region unimaginably cold, far beyond the Kuiper Belt, or it carried a chemical fingerprint not of this solar neighborhood at all. Meanwhile, the Swift Observatory turned its ultraviolet eye toward the object, scanning for the classic fingerprints of water and hydroxyl, the telltale signs of a living comet. Those familiar emission lines at 308 and 160 nanometers should have stood out like flares, but in the data, they were barely there. Instead, the carbon monoxide band glowed stronger than expected, once again hinting that the balance of volatiles was deeply inverted, as if 3I Atlas had been sculpted by conditions alien to our sun's influence. At the same time, deep in the Atacama Desert, a team using the Very Large Telescope's Force 2 polarimeter recorded another anomaly. Polarization, the orientation of light waves scattered by dust, tells scientists about the size and texture of those particles. Most comets, at a 7° phase angle, display positive polarization. 3I Atlas, however, flipped the script. It showed 2.7%, a negative polarization where no comet should. That wasn't a minor deviation. Only a handful of comets have ever dipped into negative territory, usually due to very fine, mirror-like grains. But the inversion angle here, where the polarization flips from negative to positive, appeared at just over 17 directors, not the usual 21 directors. This small shift told a big story. The dust around 3I Atlas wasn't like anything cataloged before. It reflected light in a way that suggested tight, possibly metallic alignment, or material so smooth and compact it barely scattered light at all. Then came the Hubble Space Telescope, observing invisible light. What it saw defied every textbook image of a comet. Instead of a luminous tail streaming away from the sun, 3I Atlas displayed a faint sunward halo, light scattering toward the sun, not away from it. The geometry was backwards, the intensity asymmetric. Models tried to explain it. Perhaps a jet aligned just right, perhaps forward scattering from unusually compact grains, but none of them fit. The pattern looked less like a dust tail and more like a directed reflection, a fan of light shaped by structure, not by randomness. And then came the detail that stopped everyone cold. The VLT's ultraviolet spectrograph picked up a spectral line belonging to neutral nickel. On its own, that would be surprising, but not impossible. Yet the expected iron line, always stronger in every other comet ever studied, was completely absent. In cosmic chemistry, iron outnumbers nickel 10 to 1. They vaporize at nearly identical temperatures. They dissociate under sunlight at nearly identical rates. To separate one from the other is nearly impossible. And yet 3I Atlas seemed to do exactly that. 5 observatories, 5 distinct anomalies, a carbon dioxide-rich coma, suppressed water lines, negative polarization, a sun-facing halo, nickel without iron. Each discovery deepened the mystery instead of solving it. This was no single wavelength illusion or trick of perspective. It was a multi-instrument enigma, a puzzle that refused to fit within any known category of natural object. And somewhere in the quiet corridors of JPL, scientists began asking a question they never thought they'd utter aloud. What if this thing isn't just passing through our solar system? What if it was sent? By late August, as the telescopes of the world strained to understand what 3I Atlas really was, a different kind of observation began circulating. Not through observatories or research institutes, but through obscure corners of the internet. In private remote viewing forums, a small group led by Bertie Dworsky began a series of blind sessions. Their participants had no context, no coordinates, no name, only a prompt to describe an astronomical object of current interest. One by one, they spoke of the same vision. A thumb-sized device, metallic and cold, embedded within a much larger icy mass. Some mentioned rhythmic pulses, faint repetitive emissions, like a beacon echoing across the void. Others described intricate markings etched into a smooth surface, symbols that looked deliberate, like some kind of cosmic graffiti. None of them knew what they were describing, and none were told that their target might be a newly discovered interstellar object. Yet when the sessions ended and the context was revealed, the descriptions aligned eerily well with what astronomers were now seeing in data. Of course, by scientific standards, such claims carry almost no weight. They are anecdotal, unverifiable. But in the vacuum left by missing data, imagination thrives. The idea of an artificial structure hidden within an interstellar visitor spread fast, quietly bridging the gap between speculation and public discourse. And then came the silence. High-resolution cameras aboard the Mars Reconnaissance Orbiter, including the famous HiRISE instrument, had been perfectly positioned to capture 3I Atlas as it swept past Mars. The observing window was narrow, just a few hours, but it was enough to get images sharp enough to reveal structure. Yet when the moment came and went, no images appeared. NASA's usual rhythm, the stream of new Martian landscapes, the updates from Perseverance, the raw data archives, all stopped. The European Space Agency confirmed that its own orbiters, Mars Express and Trace Gas Orbiter, had also observed the flyby, but no one released the pictures. The explanation given was vague. Data under review. Behind the scenes, the reasons were more bureaucratic and more human. On October 3rd, the U.S. government shutdown forced NASA to furlough more than 15,000 staff. Only essential mission personnel remained active, tasked with maintaining spacecraft and protecting archived data. Public communication pipelines slowed to a crawl. ESA, bound by cross-agency agreements, could not publish its data until NASA's review was complete. The result was a global blackout at the exact moment the world needed clarity. For the community of astronomers, researchers, and enthusiasts, the silence felt less like caution and more like a wall. Rumors ignited instantly. Some claimed the data had revealed an unnatural structure. Others believed the images showed motion inconsistent with gravity alone. In the absence of evidence, speculation filled the vacuum. On social media, every telemetry glitch became proof, every delay a conspiracy. Forums began decoding timestamps from raw feeds, searching for hidden coordinates. What should have been a triumph of interplanetary science, the first multi-angle capture of an interstellar visitor passing Mars, had turned into a case study in institutional fragility. The truth was simpler and stranger. At the very moment humanity needed its instruments to speak, bureaucracy silenced them. For weeks, no new data surfaced. Perseverance's faint smudge remained the only public image of 3I Atlas. And in that silence, uncertainty grew roots. Was this truly just an anomaly, or the quiet prelude to something larger? Stacking up the evidence, the case of 3I Atlas reads like a hand of cards no natural object should ever hold. Every anomaly, every deviation from expectation seemed to point towards something deliberate or something profoundly misunderstood. Start with its mass. Despite visible outgassing, its trajectory barely shifted. That alone was bizarre. In every comet of comparable size, jets of gas and dust subtly nudged the orbit, altering the path by measurable degrees, but not here. 3I Atlas moved like a stone, immense, unyielding, as though it carried a density far beyond ice and dust. Then, its brightness. Unlike every other comet whose tails glow away from the sun, shaped by solar wind, 3I Atlas shone brightest toward it, a luminous fan extending sunward, defying textbook physics. Next came the chemistry, nickel without iron, a separation impossible to achieve through natural solar heating. If both elements sublimate at the same temperature, how could one appear without the other? Laboratory simulations could not reproduce it. The only plausible explanations demanded exotic conditions, magnetic fractionation, artificial shielding, or materials engineered with precision. None of those belonged to the world of frozen wanderers. Then, the polarization. Data hinted at an inversion angle sharper than almost any comet ever recorded, suggesting grains aligned with unnatural uniformity. Perhaps metallic, perhaps structured. Even the trajectory itself seemed suspiciously elegant. Instead of slicing randomly through the solar system, as interstellar visitors usually do, 3I Atlas hugged the ecliptic plane, threading perfectly through the gravitational lanes of Venus, Mars, and Jupiter. For a natural interstellar body, this was astronomically rare. For a designed trajectory, it was efficient. And then came the eerie coincidence. The path of 3I/Atlas passed directly through the same narrow region of sky tied to the 1977 WOW signal, the most famous unexplained radio burst in human history. The probability of that overlap being random was vanishingly small. Scientists tried to dismiss it as chance. Statisticians called it meaningless correlation, but for many, it was one coincidence too many. Each of these traits alone could have been an outlier, a quirk of measurement, or an illusion of data. But together they formed a pattern that resisted dismissal. A heavy, slow object, a sun-facing coma, an impossible chemical imbalance, polarization inconsistent with dust, a deliberate-looking orbit, and a connection, however faint, to one of humanity's most haunting cosmic mysteries. To deny the pattern was to ignore the math. To accept it was to challenge everything we thought we knew about how nature behaves. October 29th loomed ahead. Perihelion. The moment when 3I Atlas would make its closest approach to the sun just 1.4 astronomical units away. For astronomers, it was the make or break point. If this was a comet, heat would awaken it, outgassing would spike, the nucleus might fragment, the coma would bloom. But if this was something else, something constructed, its behavior might defy every law we expect. Trajectory meant everything. Just weeks earlier, on October 3rd, the object had swept 29 million kilometers past Mars, a near miss on a planetary scale. From there, it accelerated fast, reaching speeds of nearly 68 kilometers per second by late October. After perihelion, it would slip behind the sun, invisible to Earth-based telescopes. Only the most sensitive instruments could catch it before it vanished again into interstellar darkness. And as scientists prepared for that moment, one phrase began to echo quietly among those following the data. If 3I Atlas is natural, we'll know soon enough. But if it isn't, we might never know at all. As October faded into November, 3I Atlas raced toward the sun, its speed climbing past 68 kilometers per second, its orbit carrying it into the inner system where only the most resilient instruments could still follow. For weeks, the object would be hidden behind the solar glare, invisible to ground-based telescopes, but not to everyone. Far beyond Earth, the European Space Agency's JUICE spacecraft, designed to explore Jupiter's icy moons, had quietly scheduled a window between November 2nd and November 25th. During that period, its optical sensors and plasma instruments were reconfigured to track faint, fast-moving bodies. If 3I Atlas fragmented, shifted, or flared in brightness, JUICE would see it. It was a rare chance, the single bridge between speculation and data. Then, in early December, astronomers prepared for the re-emergence. As 3I Atlas climbed out from behind the sun, its position would be rechecked against JPL's ephemeris. Even a minor deviation, a few arc seconds, could hint at new forces at work. Asymmetric outgassing, internal propulsion, or something yet unnamed. The final checkpoint was marked for December 19th, 1.8 astronomical units from Earth. The last opportunity for Earth's telescopes to catch it in high resolution before it disappeared forever into the interstellar dark. But even as scientists focused on observation, the world above them spun faster with rumor. A photoshopped image of Michio Kaku grinning beside a glowing comet went viral, paired with fake quotes about extraterrestrial probes. In Russia, state outlets suggested a Western cover-up. Online, the hashtag #Harbinger trended for days, a mix of panic, parody, and fascination. Yet behind the noise, the scientific world rallied. The newly commissioned Vera Rubin Observatory triggered a coordinated global campaign. Dozens of observatories from Chile to Japan aligning to triangulate the object's position with parallax precision. At SETI, researchers tuned their arrays to 1420 megahertz, the hydrogen line, the frequency of choice for anyone hoping to find an intelligent whisper in the static. And amid the chaos, a strange duality emerged. While misinformation raced ahead, so did human determination. Amateurs and professionals alike synchronized their data. Forums once fueled by conspiracy turned into collaborative hubs, cross-checking every claim, every frame, every coordinate. Elsewhere in the cosmos, nature reminded us of its own unpredictable rhythm. A tiny asteroid, just 2 meters wide, skimmed a mere 419 kilometers above Antarctica, unseen until hours after passing. On Mars, leopard spots rich in organics were found in Bright Angel Canyon, stirring debates about life. Earth itself shuddered under geomagnetic storms, auroras flaring as far south as Colorado and Hungary. And through it all, that single faint smudge from Perseverance, the image that began it all, remained our most haunting proof. The story of 3I Atlas, like every great mystery, balanced on a knife's edge between discovery and doubt. 5 major observatories had confirmed its strangeness. Carbon dioxide-rich composition, nickel without iron, polarization beyond the norm, a sun-facing halo, and a path through the sky that mirrored the echo of the Giuao signal. Yet no high-resolution orbital images had ever been released. No one outside the institutions had seen the full truth. As of now, the scientific verdict remains incomplete. The 7 anomalies that define 3I Atlas stand unchallenged, but the explanation behind them still waits behind closed data vaults. International teams continue parallax checks, while JUICE transmits fragments of raw readings through deep space channels. What we know is extraordinary. What we don't know, even more so. Until those images are made public, the debate will remain suspended between wonder and silence. And somewhere out there, beyond the reach of sunlight, 3 Atlas drifts on, leaving behind a trail not of dust, but of questions. This is Lumora, where science meets mystery. And the universe once again reminds us that what we see is only the beginning of what is really out there.